All right, this is applications part 3, and this is the last example that I'm going to do about quadratic functions used in a contextual problem. Now, I've already written this one up, and it reads, a study shows that 150 tickets out of 200 are sold if one ticket costs $25. With every increase of $2, 10 fewer tickets are sold. What ticket price would maximize profits? Okay, so that's what we're up against. Basically, we want to try to make the most money here, but we don't want to overcharge people because then fewer people show up and we might make less money. So here's how we're going to tackle this one. So I'm just going to clear the screen here. First thing is, how do you get profits? Okay, so you've got to be aware of the following way that you get profits. You take the number of tickets that are sold, number of tickets, and you multiply that by the price per ticket. Okay? So that's how we get profits. Obviously, this is the function we wish to maximize, the profits. And before we start jumping into some math, we got to figure out, well, what should x be? What is the unknown quantity here? So I'm just going to put on the side, and I'm going to let x, so x is the number of increases, number of price increases. Okay? In other words, it's the number of times that I increase the price at $2 per increase. Okay? So we know right now that the sort of information was given with $25 a ticket, so I might increase it up to $27, I might increase it up to $29, and x is how many times we do these price increases. So if we go over here, okay, then I think we can figure out quite easily the number of tickets that are sold. We know that we were selling 150 tickets, and we're going to lose, we were told, 10 tickets for every price increase. So this would be take away 10 times x. Okay, so in other words, say you increased your, you went from $25 to $27. That's one price increase, so we would expect the number of tickets sold to drop by 10. So if x was 1, we would drop by 10. Alrighty? And we're going to multiply that by the price. So how are we going to figure out what the price is? Well, the price is $25 plus $2 for every price increase. Okay, so x again is the number of times that you increased, and for every one of those, since we're going up by $2 each time, you're adding 2x. So this is the function that we are going to try to maximize. Okay, what we like is that there's already just the one variable here, just the x on the right side. So it's really all set to go. All we want to do is expand out the brackets. Well, that would mean 150 times 25, which is 3,750. And then we have 150 times 2x, so that would be 300x. Then we have negative 10x times 25, so that's negative 250x. And finally at the end, negative 10x times 2x is negative 20x squared. Okay, so I'm going to rearrange it a little bit. So we have negative 20x squared, and then 300x minus 250x is plus 50x, and finally we have plus 3,750. Now, if we go to using the vertex formula, we can find out where the maximum is going to occur. And again, we really don't care about the y-coordinate. It's the x-coordinate that's important for us. And in doing that, well, we need a, so a is negative 20, and we need b, b is 50, Now C is the 3,750, but here's the thing, we don't actually even need C in order to get just the x coordinate, right? So we don't even really care about this guy. All right, what do I need? Well, I need negative b, so negative 50 divided by 2 times a, so 2 times negative 20. So that's going to give me the following number. I got negative 50 over negative 40. Okay, and that I'm going to turn that into a decimal, which is positive 1.25. Now what that means is x is 1.25 to obtain a maximum. So we're doing 1 1/4 of these price increases of $2. So let's have a little look what that really means as far as our ticket prices. It means our ticket prices are going to be $25 plus 2 times x, and x is 1 1/4. So we're actually going to be charging 25 plus 250, which turns out to be $27.50 per ticket. And that's going to give us our maximum profits. And with that, I'm going to stop with this particular question.